All right, here we go. So on number 3, we're solving. You've got fractions and you got an equal sign. When you have fractions and an equal sign, we're going to start off by finding the LCD. My LCD here are these two things. It is both of them, x minus 4 and x plus 6. Since there's a fraction and an equal sign, I'm going to multiply everything by x minus 4 and x plus 6, every numerator. So I'm going to multiply this by x minus 4 and x plus 6. And I'm going to multiply this thing by x minus 4 and x plus 6. If you do it right, if you found the correct LCD, when you put these together, it's going to cancel. So as I look at this first section here, I'm looking for things that can cancel. Well, I've got an x minus 4 and an x minus 4. Those go away. And I'm left with 3 and x plus 6. So when I distribute that out, I'd get 3x plus 18. Then I'm looking at the next fraction. So looking at this fraction, so this stuff with that stuff up there as well, I'm looking to see what I can reduce. In this case, I've got an x plus 6 and an x plus 6. So I'm left with x times x minus 4. So that would get me x squared minus 4x. What am I going to have to do with this thing over here? I'm going to FOIL. X times x is x squared plus 6x minus 4x minus 24. I'm going to combine some like terms. So you can do this at different paces. I'm going to write out some like terms here before we do anything else. So I've got x squared. This and that gets me minus x plus 18 is all equal to x squared. Those things together get me plus 2x minus 24. I'm going to cancel out the things I don't need. So in this case, I've got an x squared on this side and x squared on that side. They're the same, so you would like subtract x squared from both sides, which would end up canceling because you have subtracted on both of them. Let's add x to both sides. So I get 18 equals 3x minus 24. I'm going to add 24. 18 plus 24 is 42. What would I need to do at the end? Divide by 3. 42 divided by 3. X is 14. There's my answer on that one. That one's the tough one. Again, I'm going to tell you over and over again, that's the hardest question on the final. After that one, which let's go to number 10 in particular. That was one we struggled with a little bit as well. So 10 is similar to what we just did, but different. In this one, the biggest difference is there's no equal sign. When there's no equal sign, we're getting an LCD, but we want to get an LCD, meaning we want the denominators to be the same so that I can subtract them, because in the end, I'm going to get the same denominator. It's not getting rid of denominators if there's not an equal sign. We're not solving. Okay, we're getting a fraction. So my denominators in this problem are 6 and 3x. What could my denominator be that goes into 6 and 3x? You could do 18. 18 works, but does 3 go into 6? Yeah, it goes in evenly. So instead of making it 18, you can do 18. That's fine. I'm just going to do 6x because I could multiply 3 by 2 to get me 6. Okay? What would I need to multiply this first fraction by to get me 6x on bottom? Just x. That's got a 6. I need to multiply top and bottom by x. And if I do that, I get 6x like I wanted. And on top, I'm going to get x squared. What does this next fraction need in order to get me a 6x on bottom? I need to multiply top and bottom by 2. So on bottom, I get 6x. On top, I get 10. Now that I have common denominators, they're both 6x. Now I can just do the problem. I'm going to just keep the common denominator. And on top, I'm doing x squared minus 10. X squared minus 10. I'm subtracting. They're not common denominator, or they're not like terms, so I can't combine them. Bless you. So I'm just done right there. Which other ones in particular do we want to look at? Is there one that you guys were looking at that you thought you needed more help? 8. I got a lot of questions on 8. Let's do 8. All right? So lots of things you could do on 8. The fraction threw some kids off. Some people, I think it threw them off because it flipped sides. Who cares that it flipped sides? If I wrote it like this, it's still the exact same problem. Okay? Don't let that be weird to you just because the 1 over 27 came first. I'm trying to solve for x. X is in my exponent. What do I do to get rid of that 3 to a power part? Log base 3 to both sides. Log base 3 to both sides. When I do that, 3 and log base 3 cancel. And then I got to do log base 3 of 1 over 27. Some of you were mesmerized by the ability to type that into your calculator. Math button. Down to log base. Log base 3 over, and then 1 over 27. 1 divided by 27. You don't have to do anything fancy. Just type it straight in. It's negative 3. Then I just solve it. Now it's just a normal math problem. I'm going to subtract 9. 4x is negative 12. Divide by 4. Divide by 4. X is negative 3. The other thing we could have done at the beginning is we could have rewritten both sides to be the same base. I could have rewritten 1 over 27 as 3 to the negative third power. Negative to get me a fraction, and 3 to the third gets me 27. Then we could have canceled and solved. It's the same exact problem. It doesn't matter how you would have done it. Both this step right here is exactly the same as that step right there. It just depends on how you want to get there. Sure. Number 7. Yeah, a lot of people struggled with 7. Remember, 7's easy. It's multiplying. Well, how do we multiply fractions? One giant fraction straight across. So we're just multiplying. 6 times 4 is 24. I've got x to the 7th and another x. So how many x's do I have now? It's x to the 8th power. I just add the exponents. And this one's y cubed. On bottom, I've got 3 times 2 to get me 6. X to the 4th, y to the 5th. I multiplied it together. Once I multiplied it together, I'm just simplifying. So I'm going to reduce 24 over 6 gets me 4. Then I'm asking myself, where is there more? I've got x to the 8th and x to the 4th. Where are the x's going to end up, top or bottom? Top, and I subtract. 8 minus 4 is 4. I got y to the 5th and y cubed. Y goes on bottom, and it's squared because I'm going to subtract. Questions with something there?